Thank you so much for joining us for today's webinar on reimagining enterprise storage, flash performance, and disk economics. My name is Soumik Ghosh. I'm Senior Assistant Editor with the Economic Times CIO, and I'm glad to be your moderator and host for this webinar. Now, in today's data-driven economy, cyber threats, especially ransomware, have become a major business risk. Over 60% of organizations have been impacted, and the recovery costs average over $1.4 million. Now, as a result of this, data resilience has emerged as a strategic priority for CIOs. 75% actually identified as a top concern. However, many organizations face limitations with overburdened data centers and legacy storage systems that struggle to deliver the scalability, performance, and security that's required in a modern enterprise. Now, to stay ahead, enterprises must reimagine their storage infrastructure to build a more resilient, secure, and future-ready data foundation. And today, in our webinar, we are going to learn how to do just that. And for that, let me welcome today's guests. We've got Deepak Yadav. He's the Brand Technical Sales Specialist, India and South Asia at IBM. Deepak, thanks so much for joining us. It's a pleasure hosting you.
Thank you. Thank you, Soumik. Looking forward to it.
Absolutely. And let me also welcome Saksham Mathur. Saksham is the Technical Marketing Engineer and Product Manager, Software Networking Portfolio at IBM. Saksham, good afternoon and welcome to today's webinar.
Good afternoon, Soumik. Thank you.
All right. Now, today we are going to be talking about storage, especially with respect to flash. In addition to that, we are also going to be talking about connectivity. We are going to be taking a deeper dive into server-to-server connectivity, and we've got a whole lot of ground to cover. So let's tune in. With that, Deepak, let me hand it over to you. Take it away.
Thank you, Soumik. Let me just share and get started. Just let me know when it's visible for all.
Yeah, we're good.
All right. Thank you everyone for joining today. My name is Deepak Yadav. I'm an SME in IBM Storage breed, and today I'll be taking you through what's new, the edge of technology IBM Storage has in the industry per se. Before we get into the technical details, there's two polls that I wish to have with you. Team, if you can bring in poll one.
Sure. Let's launch poll one. And audience, I just want to remind you that we want today's session to be highly interactive. We want a lot of questions from you. We have a lot of poll questions for you. And do share your responses with us. All right. For the first poll, what are the key concerns on data storage systems apart from performance? Is it data migration upon hardware lifecycle, ransomware threat detection, recovery capabilities from cyber attacks, or is it the increasing footprint in data centers?
And Soumik, do stop me, break me in between if there's a good questions around.
Absolutely, yeah. So, audience, do share your questions with us in the Q&A box. Deepak and Saksham here are more than happy to answer your questions. So do feel free. Do share any questions you may have on storage in the Q&A box, and we'll have them addressed for you. That said, okay, I think we would have got enough responses. Team, can we close the poll and have a look at the results? All right. So, the key concern, 33%, a third of the audience actually says data migration upon hardware lifecycle. And this is tied with recovery capabilities from cyber attacks. That is one scary thing. The second option, or the second most, goes to increasing footprint in data centers. Okay, so Deepak, in line with what you've expected, in line with the experience you've accrued when you're interacting with executives in enterprises, is it data migration and recovery capabilities? Are they the biggest concerns right now?
So biggest concerns are obviously towards the legacy concerns are, handling those data, increasing footprint in the data center. But now today, the customers are also very concerned about the ransomware of sort of cyber attacks, and how do we recover for them? How do we protect data? So that's the one I see very frequently being asked. Let's go to the second poll, and then we'll go into T2.
All right, team, we've got another poll for you. Thank you for sharing your opinions on the first one. Let's have a look at the second poll, please. Okay, so what's your opinion on who manufactures flash drives? Are they storage OEMs like IBM, Dell, HP, etc., or are they third-party manufacturing firms, Samsung, Seagate, etc.? Or do you think it's both? This is going to be an interesting one. I'm really keen on knowing what the audience has to say about this. Fairly simple option there. Is it the first, the second, where you're talking about OEMs, or is it third-party manufacturing firms? Or do you think both of them manufacture flash drives? Okay, team, I think we would have got enough responses. Fairly simple poll. 60% of them think it's third-party manufacturing firms like Samsung, Seagate, and about half of them think that they're storage OEMs like IBM, Dell, HP. Deepak, tell us the truth.
Sure. I think the understanding, which is the maximum 60% of the people, is that, third party, and which is true. If you really see a storage company like IBM or Dell and HP, we are sort of collaborators, like an integrator for storage. We bring in the processors, the controllers from Intel, we get the disk from these vendors like Samsung, Seagate, and Western Digital, and then we make our own firmware and make a solution out of it for our customers to give you, a performance machine. So that's
Right.
true. But yeah, IBM, and in additional to the other players in the market, has also invested into a specific semiconductor flash research and manufacturing of a flash, which I'll talk about today. And that's where it makes both as the right option. But the larger understanding of the industry is that everyone collaborates and gets it from Samsung, Seagate, or Western Digital. All right, so
Understood.
let's get started. First, want to just set the context right. Today the organizations have a lot of data, and while cost has been a decade-old issue, maintaining so many technologies and then data growth, the cost is one prime issue that we have to manage. Along with that, performance was a challenge with the legacy storages when we had hard disk, and then we have slower performance by media. And now when we brought the NVMe flash and the semiconductors, the performance was also to an extent taken care, because the media itself was 100x better than the spinning drives. But now the availability, that's the key concern. While earlier the system was allowed to take some downtime, some maintenance windows, but today everyone wants all the applications live at all times. Generally, that's the customer expectation from their businesses, their banks. That's when availability, not just in terms of the uptime of the systems, but also the resiliency in the systems. If something happens, there is an attack, there is a disaster in the data center, there should be a capability to bring the systems back quickly. And that's where the data resiliency comes into play. And that is what I will talk about largely in this session today. Let's move forward. First one, I'll talk about a unique capability that IBM, went into developing. IBM actually took up the challenge of doing a research into semiconductor flash. A flash is, unlike the media hard disk, there's no moving part in flash. It's all cells that are there, and you pass a voltage to read and write data. So that's the basic understanding, that you need to pass a voltage to read and write the data into those cells. Now the quality of the cell makes the flash performance oriented, or how long it will run. The life of the cell is basis on the quality of the cell. And in a flash media, generally, if the quality of the cell is not good, it is gonna fail quickly, and you'll have to replace. While customers do not worry about replacements because we are under warranty commitments, SLAs, but then replacement of cells and replacement of media takes data rebuild, restoration, and all of that, sort of hindrance to the performance of the system. That's where IBM developed a capability wherein we can monitor every cell. And that's only possible when we actually do a research, because let's say I take a Seagate drive and embedded my system. I have no clue what engineering and what capability Seagate has put in that drive. And I don't have any insights coming from inside the Seagate SSD. So that's when we wanted a media which we have complete control on. And because of that, now we know the health of every cell. And I'll talk about more that why it is important. So this is first thing that IBM has done. We have gone inside, invested our research to develop a flash media, and the name of the flash media is called flash core module. Okay, so what you see on your left hand side, this is IBM media flash core module. On the other side, right hand side, it is the standard SSD that we get from any OEM. And the major change or major difference that you see is on the controller or small chip that you see. It's a logic controller. On the IBM chip, there is a large controller logic. It's basically a two core ARM processor, and it is built in to have compute resources inside the drive. And that's when we also call this drive as a computational storage device. And this processor not just can do the data processing, but it also does inline compression of the data, inline encryption of the data. So at line rate, without any overhead, we're able to do encryption of the data. So the data inside it is completely encrypted with AES 256. And we also do inline compression. Irrespective of any data, any sort of data, we do compression. And it is an inline rate, which means even if your workload is compressed at the host level or it is not compressed, there'll be no overhead, and it is by default, by design and the hardware. So no overheads, and always there, always on at the drive level. On the right hand side, if you see, there is a small processor controller chip which is embedded by the standard OEMs, and that's where it can do miraculous thing. Not a major capabilities can be embedded, and the chips on the right hand side, those are called basically ASIC chips, which cannot be the logic which is there inside cannot be altered or modified or improved once it is embedded. But on our controller chip, which is called a FPGA, flash programmable gate array, it can be tuned, it can be modified, updated basis on the technology advancements. And we have also embedded additional RAMs, capacitors to support the capability to keep the data which is there on the flash module. One more slide on the enhancements. What we have done, as I said, we have done penalty-free compression, penalty-free encryption, and we have also used QLC, quad level cells. Basically, these are more dense cells to be very on a very basic note. Quad level cells means that every cell can hold 4 bits of data, and it's more denser than TLC. But when you have it more dense, the life of the cell can degrade. That's when we have put in additional capabilities to make it more life oriented. The longevity of life have been improved to almost like 5.5x, and that's because of the research and technology that we have brought in. And if you see, this is all what we do inside the flash cells. Very interesting thing that we do is we do tiering between the flash cells. Let's say you have 100 cells. Out of 100 cells, I've marked 20% of the cells as SLC, which is single level cells. So all the hot data, which is the critical, frequently accessed data, will sit on the SLC cells, and then rest of them will be on the QLC. And that's an internal inside every drive. There's nothing of this sort is being done at the controller level. No overhead to controller of this storage. It is at the drive level. And then we also do other sort of garbage collection, efficient read calibration. Let's say I can understand which workload is very IO intensive. I always keep those data on the best cells that I have, the performance cells that I have. And I also do other sort of error corrections to ensure the QLC cells have a better life and performance than a TLC. And this is a lot of IBM research involved in this technology, and happy to take clients on a deeper dive of this technology, because it's in itself is an organization within IBM that does this.
Right.
There's a poll 3 before I go to the next slide. Any queries, Shomik, you have seen? Please bring on if it's there.
I do. So we have got the third poll question, which is, with the rising cyber attacks on organizations, applications, and data, do you think perimeter security tools are still sufficient to detect intrusion or threat? Is it simple yes, or is it a no? But Deepak, getting back to the content that you've presented so far, I think it's pretty impressive. And, the very fact that you're being able to monitor each of these cells. Now, I was just curious, what actions or what remediations do you take when you notice that the health of a particular cell is declining? Um, what's the way forward to that? Do you replace that cell, or do you reach out to the client, or how does it work?
So, without coming to the ransomware side of the solution, the primary side, when you say cells, let's say a cell is dying, quickly, and either I have to replace, but there's no cell individual replacement that can happen in the drive. So what we've done is we have added 33% extra cells inside our drives. So if a cell is about to die, I will not declare the whole drive as failure. I will replace with a fresh cell, which I have pre-provisioned, I have pre-populated them in the module so that the deployment doesn't have to be replaced. So we have seen, and as apart from other failures of the hardware, which could be some other modules, but due to a flash cell, we have never weared out a flash media. That's IBM's commit that we don't wear out the cells because of our technology.
Understood. Well, thanks for sharing that with us.
How was the poll result? If you can bring it back.
Let's have a look at the poll results. So 67% believe that perimeter security tools are insufficient to detect intrusion or threat. However, interestingly, a third of the people still believe that intrusion detection tools are enough. Deepak, what are your thoughts on this? Do you think endpoint security tools and intrusion detection is going to be enough? If not, why?
See, on the security, it's always a team game. Neither of one party can ensure, can guarantee that the attacker will not be able to get in or will not be able to hamper or destroy my data. It's basically a team sports wherein we need these parameter devices, firewalls, intrusion prevention and detection as well on the network layer. But beyond that, we have seen the data getting compromised, data getting encrypted. That's where the customers of IBM started asking, if we can have some sort of intelligence, because now AI is everywhere. Can you use AI to see the data behavior, learn the behavior of a ransomware attack, and see, if there is anomalous workload or an application which is some sort of code running on my data and which is encrypting, which is destroying my data. That's where IBM brought capabilities now, and which can actually behave and see that all the behaviors which could be a pattern of a cyber attack can be detected and informed the clients within a few seconds. So that's where I'll deep dive now.
Right, sure. And audience, I would just request you to share your questions with us in the Q&A box. I'm sure you would have a lot of questions. There's a very important topic. We're talking about this combined cybersecurity and, of course, storage, and we are going to be addressing backups as well. Do remember, over 90% of cyber attacks actually focus on backup storages. So do share those questions with us. We've got Deepak, we've got Saksham. They'd be more than happy to take those up for you.
First of all, when we started, making a possible solution for detection of the attacks, we thought of, this behavioral checks and test could be very intensive because monitoring any data behavior needs a lot of resources, and that's where, again, we fell back to our flash core module technology, and the monitoring of the data, the IO pattern analysis is brought inside the FPGA on the drives. So again, the capability that we have brought for anomaly detection, it is not at the controller level, it is at the drive level. And we're not missing any IOs. Okay, every write IO is being monitored for a behavior. Okay, because reads are simple, read doesn't hamper anything. But if someone is encrypting, someone is destroying my data, it's a write activity on the storage. So I'm monitoring every IO, and every 2 seconds, I take the data and I, give it as an input to my storage. And before that, so what we have done essentially is we have trained a machine learning model in IBM Cloud. Okay, that's our playground. And IBM Research has done this. And what we have done is we have taken the actual attacks, which are popular attacks from Conti or Log-Vista and Black-Vista. Those are the popular attacks that we have seen, and they have been doing it frequently across the world. We have taken them in a fenced network and seen their behaviors. Okay. and trained our models for Shannon entropy. Okay, Shannon entropy is basically a mathematical entropy calculation which does the measuring of uncertainty in the data.
Right.
Okay. Then we monitor 40 plus statistics, and the key ones are Shannon entropy. Second is compression statistics. Compression is simple to understand. When you encrypt some data, the compression ratios drops like anything. It can come from 3x, 4x to less than 5%. And that's a drastic change that can be monitored. Then there is a chi-squared voltage behavior. This is basically another mathematical calculation which checks the behavioral of data from a normal day to a abnormal attack day. And then there are behavior like, change in the read-write throughputs, because generally, if you see a standard application, it could be doing, 60% of the read activity, 40% of write. If the attacker starts destroying and deleting the data, it could come to, 90% of write activity and can be monitored and seen for an attack. Then we have LBA, logical bus addressing, sequencing pattern, and encryption payload. So all of these statistics are being, analyzed from the real attacks, and then the model has been trained. And it's not a signature based. As I said, we have trained the model to look out for the behavioral of the real attacks, and then sense the attacks that are happening on the field, because every attack is different. We cannot have antivirus kind of signature matching system for ransomware. That's when the ML model has to come in picture. And what we do, if you see the last line, we are committing to the customers that we can detect behavioral under 60 seconds. And we have kept this under testing for last 2 years. And this year we have, opened it up for every customer and see, because there were false alerts in the start, but now we have matured enough that the false positive are very limited. And maximum time we are able to do it a detection of the attacks. This is how it happens in reality. Every drive, every 2 seconds, give an input of statistics of every IO which is being monitored. And there is an inferencing engine that we have got it from our machine learning model. That inferencing engine is logic is inside the storage controller firmware. And then it is compared against the statistics, and then customers alert. We can also push the alerts to emails, and we also push it to IBM support, so that, IBM support can call you as well to, alert you. That's where the capability comes in. So this is again anomaly detection. Okay.
Right.
Now, when we move ahead, obviously, once I've detected, customers can take steps towards, either fencing the application or stopping the application, fencing the networks, and additionally, what IBM storage has brought in is a feature called immutability. What we can do in immutability is we can configure creation of automated copies. You set a frequency, let's say a frequency of 30 minutes. My database should create a immutable copy every 30 minutes and should retain it for, let's say, 48 hours. Okay. So this copy that gets created cannot be deleted even by the storage administrator. Okay. So we fence it that hard. While it is there in the same storage, logically air gapped, even the administrator cannot delete it. And it's again incremental copies. So it's not the full copy. Let's say my workload is, let's say database is 10 terabyte. I don't need 10, 10, 10 every 30 minutes. Only the differential change that happens every 30 minutes. I keep that as a bitmap tracker, and I only need differential space. So the requirement of the space is very limited. And this feature is embedded in the storage. IBM doesn't charge any license for this. You can configure on your will. And that's where this becomes the first point of restoration when there is an attack. You'll get multiple copies to look through. Let's say 48 hours, as I said, you will have 96 copies. If the attack has happened and we are late to identify, you will still have almost 96 copies to go back and see which copy is good. And then you can restore and start your business back. The restoration or checking doesn't need a full restoration. It's within few seconds, like a snapshot, you can mount it and check it for it. And then once you're comfortable that, let's say, a copy which is 6 hours old is a good copy. I want that copy to start my production back. Then you can initiate a full copy, and the copy will happen in background. You can start your business right away from that copy. And this is how it works. I keep taking copies. in the example, it's every 3 hours. If you see in the bottom, there are multiple safeguarded copies. All of them are non-addressable trackers only. Okay. So what happens is when you want to check back for any of the good copies, you will actually have to create a recovery volume from the saved copies. Only then you will be able to test this for validation and then use it for production. So let's say in this case, the fifth copy and the fourth copy were already corrupted. So I went back to the third copy and then I found that this is a good copy. Then you restore it either to production or you can restore to any other server and start your business back. That's the point of view IBM has today.
All right. Fair enough. That was some great content covered there. All right. Now time for our fourth poll. And we have already started getting audience questions. We've got one from Mr. Rajnikant Ghodasara. Rajnikant, we're going to be taking this question towards the end of today's webinar. But before that, we've got poll 4. Okay, so what is the most challenging part of storage hardware refresh? Is it storage model selection, cost approval, data migration downtimes, or is it the stabilization issues post migration? Okay, this is going to be interesting. Let me know what the audience thinks about that. But Deepak, yeah, I mean, again, providing about 90% surety. Nobody makes guarantees in cybersecurity, but that's pretty bold of IBM to do so. I was just curious, Deepak. Now, you did tell us that you've been able to reduce the false positives. How are we able to, figure out false positives is one major concern when it comes to cybersecurity threats. And we know that, a lot of SOC analysts can be buried under the number of threat volumes. So if there's a measure that can cut back on false positives, I think that's a huge advantage. How did you achieve this at IBM? We're going to discuss that shortly, but before that, let's close out the poll and look at the results. 55% say stabilization issues post-migration, and the next majority at 27% goes to data migration and downtimes, followed by storage model selection. So stabilization issues post-migration is one of the biggest challenges when it comes to storage hardware refresh. All right, thanks for sharing that with us, audience. Deepak, over to you. Tell us a little bit about, how does IBM go about false positives?
Yeah. So basically, when we got this feature developed by IBM Research, we did not release it for our end customers right away. Initially, we kept it under the monitoring of IBM support, and for almost 2 years, only the observation was happening, the analysis was happening, but it used to only go to IBM support for any validation, second validation, and then the customers were informed. And we used to call back in customer and see there is a behavioral pattern. Do you see this is a right attack or just a false alarm? And we started getting feedbacks that they were doing some sort of cleanup and they were actually doing some fence networking checks on their validation. And then we started learning some behaviors are human created and some are not human created. So then we started learning, and now after 2 years we have started giving to the clients direct inputs on the tags. So after even release, we actually waited for 2 hours of further research and customer inputs testing, and then we brought it.
All right. With that, I think it's time for another poll.
I think I got the poll done, right?
Yeah. All right.
So that's where I was coming to, in the traditional approach of storage systems, one of the key challenges that I see is data migration. Customers after 5 years or 3 or 5, between 5 to 6 years, they have to do a refresh, and that's where the challenge of data migration comes in, especially for applications. How do we migrate the data? Can we do it on the storage based? If it's storage based, is it without the downtime, or how much downtime do you need? My application team, my business team is not ready for downtimes. There's a lot of challenges around downtime these days. As I said, availability, 100% availability is the ask of the business and the clients today. That's where IBM brought a capability called IBM FlashGrid. What we have done is we have brought in a capability wherein we can migrate the data seamlessly from one system to another system without any downtime. Like we have virtual machine migrations in VMware world. We have started volume migrations between physical hardwares. And these can be between disparate models in IBM storage. It doesn't have to be same family. It's not like a standard clustering earlier, wherein we could do that, two same or model systems in a clustering can migrate and move data between them. But now we have brought in between disparate systems. It could be one entry model and one enterprise, and you can migrate the data between them online. There'll be a multi-path failover, which is seamless, and we can demonstrate that live. This is a very recent feature, and this will ensure, when there is a migration needed in the data center, you don't have to go to business teams and ask for downtimes. It's gonna be non-disruptive for you. If you see in the diagram below, the same use case can also be used for moving the workloads between different systems that you have. Let's say you have created a grid of, let's say, 5 systems, and some of the critical workloads which were initially into test and dev, new development, now they have grown into a large critical application. You want them to be moved to a bigger system in the grid. You take them from a smaller system to a bigger systems, and some workloads which are not very critical now, you want to bring them back from an enterprise storage to a smaller unit. All of them can be done seamlessly. And this, while a human administrator can do all of these basis on his intelligence, but we've also brought in the intelligence of AI, which will suggest you that these workloads can also be on these. This can be migrated here. This needs more, and the growth rate, if this workload is much higher, you may plan it to take it to a better or high performance storage. So that's where we have brought in the automated analytics as well for you. I think I would summarize here, but if you, Shamik, any queries that I should answer before I move it to summarizing my content?
Absolutely. We'll take this one from Rajnikant, although it's not completely aligned to what we have covered today. But then I think Rajnikant would want to know, tap into your expertise out here, so if you can help him out with that. So Rajnikant here is asking us, please share your innovative thoughts on secure data storage technologies like blockchain technology, etc. Don't think you've covered blockchain here, but then if you could talk about some emerging technologies in secure data storage, that'd be great.
I think blockchain comes completely on a different track of technology. What's the second statement you added? Secure
data storage technologies. So blockchain, I know for a fact that they find very little use cases in this domain. But then, is there any other technology that you're exploring at IBM, or any other technology that you're aware of when it comes to secure data storage?
Nothing sort of that comes into this domain of storage technology. But let me check out if I can find something. But not at the moment. These are completely two different subjects.
All right. I was just curious, Deepak. Now, you've done a fair bit of research at IBM. So when it comes to trying to secure enterprises from within, that is, if you're working on the storage part of it, trying to secure that, versus you're trying to secure the enterprise from a boundary, from a perimeter level, with respect to endpoint security tools, how do they fare? You've seen a comparison between both of these. If you could just give us a ballpark figure with respect to both approaches, which one has done better in your experience?
See, as I said, this is a team sport. 90% of the chances, the threats get detected at the firewall, at the perimeter itself. But
Right.
The rest of the 10% which gets in, and once they are inside, they can stay inside for a while. You've seen the attacker sits inside the environment for a while, sees what's happening inside, what are the behavior of users, where is the backup solution in the environment, then finds the that sort of metadata there, and then one fine day when he knows everything, that's when he starts to attack. So until he is not attacking, then they have crossed perimeter. They have not started the attack on the storage. They're just
Right.
inside. That's where you need malware scans. You have to scan the system and see if there is something unwanted code which is doing some sort of checks on the environment. If malware scan cannot scan it, it gets unnoticed, and then they start the attack on the data. That's where our capability will come in. As soon as the attack starts, we will get to know, and we will notify the customers. And for this information of anomaly will also be passed on to clients security tools like QRadar or SIM tools, and then they can take further actions. From a storage angle, then they have immutable copies for the data to be restored back. So what we have brought in is anomaly detection. We have brought in immutable copies for restore the data back. So all the three layers largely has to work in, and all of them are important as per me.
All right, understood. Go ahead, Deepak.
All right. So just to summarize, IBM Flash System today, is helping clients to reduce the operational cost because we have very high dense Flash systems. We also have a single Flash module of 46 terabyte, single drive, and it can do compression in the tunes of 3x. So in one single system of even 1U, we can pack, more than 1 petabyte of storage. That's when very dense capacity. And then when you have multiple systems, you can move the data between the systems. Could be for just management of the data or could be for hardware refresh. That's when the Flash system grid comes into picture. We also have reduced the power requirements, and because of these capabilities in the Flash media, we have almost brought with the competitor, we have do an analysis of ESG reports, and we have seen 29% reduction of energy requirements for IBM Flash systems. And if you see the metric here, we have set in 1 watt per terabyte as our ESG goals, and we have there to attain that. And at the best, we do a guarantee 60-second information of anomaly detection from our systems for the customers. So that's the summary. I'm open to questions and deeper dives from our clients on the call. Do reach out to IBM for them.
Absolutely. All right. Rajnikant, of course, is saying blockchain offers several key benefits. No denying that, Rajnikant. We've seen several uses of blockchain, but I just don't think IBM is using it for their, their Flash system out here. That's the only reason we didn't delve into blockchain being used as a security measure. But yes, you're right about that. There are certain use cases, and yes, they have proved their worth when it comes to encryption, secure encryption. We've got one question coming in from Dinesh Rana, who's asking, is Flash storage expansive? I guess he means expensive. So only critical data can be stored on Flash and the other things on normal storage. Tell us about the economics of this, Deepak, because we know for a fact that, be it a CIO or a CISO, one of the most important things is making the most of your security investments. So if you're investing in Flash, is it going to be too expensive? Or how does the economics work out?
So enterprise level quality of Flash, which I talked about, obviously it's expensive because the performance of peak and then all the other capabilities that come in after research. But we've also brought in a new model called Flash System C200. It's a new category, even mentioned by Gartner now, wherein every OEM should have one Flash system offering, wherein it is very dense and at a very cheap cost.
Right.
That's where the answer is. If you have a workload which runs on, let's say, a hard disk, and the volume is high, could be for like for example, backup on disk, hard disk, NLSAS, you can move it and replace it with the Flash storage, which it's very dense. So because of the dense and because of the new technology which is making it dense, brings the cost down, and also at the same time with the compression, you can have 2x the capacity. Okay, because on HDD there was no compression. Okay,
correct.
So let's say you need 1 petabyte, you need 1 petabyte of spinning drives, that capacity. But in Flash, let's say you only have to need, let's say, 500 terabyte of Flash because it can do 2x of compression. So in 500 terabyte, which is less space, so you save on the data center, it is much denser, and the price is also cheaper of this Flash cells on the C200 models. So that's where the technologies are. We have offerings for making it comparative to HDD as well today.
All right, Dinesh, I hope that answers your question. One more question from Pratik that I would want to take up. So Pratik Mishra is asking us, which AI model are you using for this malware detection? And what is the area where we need to focus on in the coming days as part of research? So first, the AI model, is it custom built? Or if you could tell us a little bit about this AI model, even though it could be proprietary.
There are certain proprietary and patented technology, but I must say there is LSTM that we use, LSTM, and There are few more which I've heard from research, but it's not completely brought in open because of the patent technology. So that's the first answer. We use LTSM and few others inside it. What's the
All right.
second question? There was a add-on question, I think.
No, there was no add-on question there. Just which area do you think we should be focusing on, in the coming days as part of research? So if you could tell us in IBM at least, what research are you focusing on?
Especially, we are also researching on, likewise, we have always been using flash or fiber channel based storage systems. Now industry wants to move towards slightly low expensive TCP or network based storages. And there's a lot of investments in research for a fiber channel, similar performance and the uptimes and the, less of data loss through network protocols. So we have Rocky protocols coming up on the TCP IP,
Right.
which is equivalent and alternative of flash core model, which is getting popular, not in India as of today, but outside India. I've seen markets like Canada and North America, wherein they have started to utilize Rocky-based storage systems. So that's one key area we are working on. Another are always about optimizing how the data migration happens. That's one key area we are working on, how to make it seamless for data to be migrated across machines.
All right. Pratik, I hope that answers your question. Thank you for addressing that for our audience there, Deepak. We've got one coming in from Mukul Agarwal who's asking, what is the form factor of C200 and the capacity options?
C200 is a 2U machine, and it's a fixed capacity machine. It comes at about 750 terabyte of usable capacity after the formatting of the data drives. And we promise minimum 2x capacity on the compression, while it can do much better. But then on a average, we see easily to achieve 2x. So you'll have about 1.5 petabyte of usable capacity on 2U machine, and comes
Right, I think
with feature bundle of safeguarded copy, ransomware detection, all of that comes in. And these are all based on flash core modules. So you get that resiliency that we talked about in the start.
All right. Okay, Mukul, I hope that answers your question on the C200. All right, so we are done with the questions out here, Deepak.
All right. Short on time, I'll hand it over back to you. Thank you.
Yep, thanks so much for that. All right, folks. Now, we know for a fact, we've talked about storage. We know, how Flash can take care of that. We'll now talk about connectivity, especially we're going to be looking at server-to-server connectivity. Now, you need high performance and resilience in the network and the hybrid work environment as well. And this is where hybrid mesh comes into play. And to talk about that, we are going to bring back Saksham Mathur. Saksham, over to you.
Hey, thanks, Somik. So it was a pretty insightful session, and so the two takeaways from this session, and that it's we'll be making the how will I be connecting the dots to our next conversation is obviously the cost is not a challenge, right? I mean, from the poll results that we have seen. But one important factor is the right data at right time that we have seen on the slide one. And the other thing is about the security. So we saw the poll results of talking about the perimeter devices, not really only the important things, right? There could be issues with that. So based on that, I will, try to bring attention towards how the connectivity is also an important role in securing your data traffic, securing your application connectivity, which could be residing in a different data centers, right? So your storage sits in one place, and your application, which why we see it like we are modernizing our application network, and application could be residing in cloud, it could be residing in data centers and on-prem. But then once it has to communicate with back to the data centers where your storage resides, the key aspect here is how you can secure that from the application layer, right? Not only at the network, but also on top of that, we have an overlay which connects those things and secure it. So based on that, I will just quickly share my screen and share the slides so that we can delve into it right away.
Sure.
Right. So connecting the storage with the modern applications is really challenging because it also becomes a bottleneck on our progress, on our scaling, and our leap towards modernizing our infrastructure overall. right? So why we need is like, applications, once they're deployed, they need to have permissions. They need to have a secure way of communicating with your storage, which could be residing you in your Z mainframes, x86, stored SAN, which is connected to that. But at the same time, you also want to have a way to, understand how your application can understand that connectivity. So you are not only relying on, say, a subnet or IP level connectivity. You are talking about the application domains itself, how your application can understand what service I need to connect to, right? So that becomes very essential for modernizing and scaling our infrastructure rapidly, so, right? So, so this is very important, and based on that, I will just try to show you a block diagram in the next slide. But
Sure.
before that, I will just give you information about what IBM, does in the software networking space. We have a portfolio of products, and out of which one is hybrid cloud mesh, which is essentially uh, a very state-of-art solution which helps you to connect your applications or server-to-server communication, as Somik said, which may be residing in different places. It could be from Delhi to Mumbai connectivity, or from a different geolocation itself, right? So it bridges that connectivity on top of your existing SD-WAN or MPLS network, or other networking that you have. So what are the benefits? Why we need that kind of a technology? It is because our infrastructure is becoming very smart. It becomes very scalable, and it becomes very important for it to adopt to a new technology to rapidly scale. At the same time, do not compromise with the security, right? So there would be an RBAC feature where you have the control by the at one layer you have the network security, but at the same time at another layer you also have the developers or the application level security, so that you have two levels of security. And even if it crosses your perimeter firewalls, or there is any issues in line with the perimeter firewalls, your application connectivity is still secured on top of it, right? So there is encryption on top of it, and it's still fast enough to have your real-time data traffic move as quickly as as you want with your storage. So what hybrid cloud mesh brings in, it's helps you to have a policy-driven layer 7 application connectivity. It has performance improvement and resilience. It gives you a way to connect your mainframes to your modernized applications. It gives you a way of connecting your VMs to your applications. So many times we see that modern applications or monolithic applications which reside in VMs have difficulty in communicating with the container-based solutions, right? So when we deploy any new applications in a container, which could be in cloud, AWS or IBM cloud, it becomes essential to provide a connectivity to that as well. So hybrid cloud mesh provides a way to just put that, a software and agent which is installed right near those applications, and it connects those two dots, right? So it's not a hardware, it's a software, it's a SaaS platform, and it just through a single pane of glass, you can deploy the small agents into those locations where you want the connection to happen, and then it can take it from there, right? So how it works and how it looks like. So till now, we had been looking at the left side of this slide where we were focusing on the storage. And now what we are trying to also show you here is, how on the right hand side, your connectivity, which is across the geos, across the uh, states, can help you bridge those connections and still enable a fast connectivity back to your storage. So with that intent, we can say like, what is an approach of application that could be residing in an on-prem, say a branch office, or say in a cloud environment, how it would look like. So there could be front-end applications. Say you have a loan application, it could be residing in somewhere outside which needs to communicate back to your database systems, and then it reaches through your Z mainframe or x86 or whatever architecture you have, and it queries your DB2 to understand, what is my database there and how can I retrieve it quickly, right? To show and put it back onto your application on the front end. So that whole flow from one point A to point B becomes really essential. And if I just quickly give an analogy here, like, if you use a Google map and you may know that, you have to reach from point A to point B, there are multiple paths, right?
Correct.
One could be a highway that you may know of, and you will by default go to that highway and you will take it. But at the same time, what we also need to see is like, is that congested? And is there any other way that you can go through? There could be a narrow road, but is that, the route that you can go through? So that understanding the whole topology is, driven by hybrid cloud mesh. It understands if you want your application, which is residing at, say, point A, to your data center where your storage is at point B, what are multiple ways to reach those? And, how can I reach it quickly? How can I retrieve my data quickly and, present it back to my application? At the same time, if there is a loophole, if there is a congestion, or if there is a network failure, we have seen so many times that, there could be server down issues, the server is not able to retrieve the data, and we are stuck in our system, right? So how can you come out of those issues and you still be able to retrieve the data if there is a failure at one point of place? And you can quickly switch over to the other road or to the other path which can retrieve the data. So that's how you can bring up your this mesh gateway technology, and it can also link up with any other new deployments that you have. Say if you have a new data center deployed in a cloud, so there it can establish that same application connectivity. You can move that application, say, from your one location to cloud, and still maintain that connectivity right away, right from the time you are migrating that. It is not that you have to wait for hours or days or weeks for your network teams to set up everything, give you an IP access, your firewalls are set up, and you are able to establish that connectivity. But what it does is, out of the box, you can move your application from point A to point B and still retain that connectivity, which is very essential. So with that, I would, so this was a brief overview of hybrid cloud mesh and what it is. I would suggest and request everyone in the audience to, have a look at the product info, and there's also a trial where you can sign up for the trial request. It's a sandbox trial request in which you can have a quick way of interacting with the UI and see how it actually works. It is a policy-based driven platform. So once you have, point A to point B connected, you can also ensure what can talk from point A to point B. Your network does that from the IP perspective, but now we are talking, above the IP layer, we're talking from the application perspective. Okay, my loan application can talk to the loan database. My loan application cannot talk to my operation database, right? So that kind of granularity is there with hybrid cloud mesh, and this is something that I would urge to explore for here. So any questions so far on based on what we have presented?
Yeah, well, I've got a question for you, Saksham. Now, Saksham, we've heard a lot of this buzz around application centricity. Is this what you've been describing? What you're doing with this particular example? And if you could tell us a little bit more in concrete terms, explain how this happens. How do you go about this?
Yeah, that's a great question. I think that is really important to understand that today the networks are or our infrastructure is expanding in multiple ways. It's not like you deploy one data center in one place and you connect that, and that's like a stack of your layer 2, layer 3 connectivity to your storage and back, right? There is no one point of in and out. There could be multiple in and out to your data centers. It could be because of your application residing in different platforms like cloud, as I said. Now, so what becomes essential here is that one IP subnet could have multiple domains, with the application modernization. So we cannot rely on restricting our traffic or securing our traffic just based on the IP subnet. But within that, how I can restrict my traffic based on application domains or application way of, securing the tunnels. is also becoming essential. So we are also making sure that L7 layer, which is your talking point of your web pages, your mobile applications back to your storage, to only pull the data that is really required, and there is of everything else is like blocked from the application perspective itself, rather than just relying on the network.
All right, team, and you would have got a message in the chat window from etcio.com. Those are the two links that you can actually check out for the IBM Hybrid Cloud Mesh, the one that Saksham has presented on the screen here. We don't have any questions around the segment from the audience, but I've got a question, a couple of questions in general with respect to cybersecurity and, of course, storage. I'm going to route this to you, Deepak. Now, Deepak, in your presentation, you spoke about always-on compression. You explained about Shannon entropy. If you could tell us, how does this help detect cyber threats in near real time? And also, what other capabilities do you actually bring to the table with respect to identifying anomalies? Are there any other patterns that could identify an attack?
Sure. So on the compression level, I would say it's a great feature that we have. While earlier we used to have software-based compression, which used to consume controller cycles, CPU cycles. That's where we started, stop that feature and brought in the drive level, which ensures there's no impact of compression. And we have core banking databases, core databases running with compression enabled. And there was a recent circular from RBI or regulators that we should encrypt few databases wherein some data was asked to be encrypted. And I would say the circulation was around PII to be encrypted. So few customers took it as encrypting the whole database. That's where they lost the benefits of compression, because when you encrypt and then write to storage, the storage then cannot see what's inside the data. And every time there is a data coming in, it will have some distorted encryption there. And when we actually went into that circular, I would say the customer should know the ask is to do encrypt only specific PI data. So you should look at which tables to be encrypted or which specific data to be encrypted, so that the entire benefit does not get wasted. You can encrypt a few tables there. And compression is one thing, and as I said, encryption gets destroys the compression ratio. So if the attacker is using a traditional encryption way of taking control of the data in an attack, first thing that will drop is compression. So that becomes the one statistics that is very easy to notice in anomaly detection. The second that you asked me about is Shannon entropy. Okay. Correct. So every IO that comes in, every IO, I say every IO, we are not missing any of the right IOs. There are competition that is claiming similar anomaly detection. But when they say they are doing a sampling of few IOs within a group of IOs, let's say 2 IOs after 100 IOs, but we are not doing that. We are doing every IO sampling. And there is an entropy mathematical calculation of that IO. Let's say 60 KB data came in. I created an entropy calculation, and I match it the entropy with the normal day behavior, and then see the entropy. And this entropy is basically a measurement of uncertainty in the behavior. So if there is a behavior uncertainty, I will bring it up to the notice of the client. And this uncertainty is already being checked of the worldwide attacks which has happened in the world, and then we have made our model to learn from there. And we're not stopping from a static learning. The newer attacks that are happening, we are also updating our machine learning model, and the updates are also brought in from there to our storage. So it's not static one time that you add in, but newer attacks will also be updated and given to the clients to update their systems. Inferencing engines will be updated for them as well.
Got it. That was a great explanation. Thanks for that, Deepak. Audience, we've got a couple of minutes more. We can squeeze in any last questions you may have. So do feel free to chip in with those questions. Now, the last question that I had, and the Saksham, Deepak, either of you can feel free to chip in for this one. And this one is about ESG. Now, folks, we know ESG is now a board level priority. If you could tell us a little bit about how does Flash score on company sustainability goals, and also what percentage, if you're talking about C200 use cases, is there any way we can manage the performance along with the sustainability goals? How do you achieve both of these?
I would say the flash, obviously the overall footprint of storage has been brought down because the flash are very dense. I had an image I forgot to show you. In 1956, when IBM invented a drive, a spinning drive, it was of 5 MB. 1956, and it was a complete tower. A complete rack, more than 2 rack size.
Right.
And around about 70-75 years now, the one single drive which I can hold, just 2.5-inch drive, can hold 46 terabyte. I can't say 1000x or more than that. So the storage is getting denser by the technology, and the amount of energy that it takes is also very small. And because of the compression ratio, it makes it more lucrative for customers to adopt. So in our ECG reports, we have mentioned that with IBM flash systems, the customers can save between minimum 29% to 46% of energy savings on the report. And even in the data centers, there are we can push almost 30% extra capacity per rack unit as compared to the earlier generation of technologies. That's our metrics that we publish in ESGs.
All right. Those are impressive numbers. Thanks for sharing that with us, Deepak. And audience, with that, we come to the end of today's webinar. I hope you enjoyed it. You learned as much as I did. I sure did. And that was Deepak Yadav and Saksham Mathur from IBM. Thanks again, Deepak and Saksham, for sharing your time with us. That's it. This is Soumik Ghosh signing off from ETCIO. You guys have a great day ahead. Take care.
Thank you.